When measuring hard-to-reach objects at long distances, the signal contains distortion. The measuring signal will contain not only frequency of the initial phase, but also a frequency of atmospheric turbulent disturbance. To explain this phenomenon, the atmosphere is represented as a set of moving vortices. For laser light, these vortices act as lenses. Lenses have a random shape and move in space with different velocities. Each vortex volume or lens is characterized by its own concentration of matter, temperature, humidity and other physical characteristics. Refractive index inside the vortex is continuously changing. Although air refractive index pulsations have small values, but their cumulative effect is significant. And as a consequence, fluctuations in the refractive index significantly distort the wave parameters corresponding to propagation in a vacuum. As a result, the light beam in the receiving plane will have a random intensity distribution, and the photodetector will register the signal as random functions of time with parameters that depend on the optical system. To achieve high resolution of optical systems, it is necessary to correct the turbulent distortions of the wavefront shape, hence reducing the influence of the Earth's atmosphere. Since turbulent pulsations occur very quickly, measurements must be taken at a very high frequency. The LDV is suitable for this purpose. It can be used to detect and remove atmospheric noise.